The universe is a vast, infinite expanse that defies the imagination. As we push the boundaries of exploration, we uncover new mysteries that challenge our thoughts of the cosmos. Today we journey through some of the most mind-boggling facts and phenomena in the cosmos. Chapter 1. The Infinite Universe. The universe, our home, is vast beyond comprehension. Stretching across 93 billion light-years, the observable universe is home to billions of galaxies, each containing billions of stars. But we've only scratched the surface. Most of the universe lies beyond the limits of our current technology, hidden from view by an ever-expanding space. The cosmos is an absolutely massive place. The light from the closest star, Proxima Centauri, takes 4.24 years to reach Earth, even traveling at the speed of light. And that's just the nearest star. It would take about 80,000 years to reach this star with our current technology. The sheer number of stars in the observable universe, estimated at around 100 billion trillion, is mind-blowing, especially when you consider the potential for unknown stars and systems beyond what we can see. The universe is also expanding at an accelerating rate, driven by dark energy, a force we cannot see, but that makes up 68% of the universe's energy content. This mysterious force continues to drive galaxies away from each other, making the universe grow larger and larger over time, further distancing us from the objects we know today. What lies beyond the observable universe? Could there be entirely new realms of existence waiting to be discovered? Chapter 2. The Big Bang. The universe had an unexpected beginning, one of unimaginable violence and speed. Around 13.8 billion years ago, the Big Bang set everything in motion. This was the rapid expansion of space itself. From a singularity, a point of infinite density, the universe began to expand, cooling and evolving into the cosmos we know today. During the first few moments of the universe's existence, it grew exponentially faster than the speed of light in an event known as inflation. Within fractions of a second, it stretched from subatomic scales to nearly the size of the observable universe. Cosmic microwave background radiation, the afterglow of the Big Bang, still radiates through space today, providing us with evidence of that early, fiery beginning. A critical discovery came in 1998, when astronomers found that the universe's expansion is actually accelerating, not slowing down as previously expected. This is also known as redshift, where the wavelengths of the light from stars and galaxies are shifted to the red side of the light spectrum as they move further away. This phenomenon, attributed to the mysterious force of dark energy, is one of the greatest puzzles in physics as we struggle to understand what it is and how it impacts the evolution of the cosmos. Could the universe experience multiple Big Bangs throughout eternity? Or are we in a one-time event never to be repeated? Chapter 3. Black Holes. When a massive star reaches the end of its life, it undergoes a collapse so intense that it forms a black hole, a region in space where gravity is so strong that not even light can escape. The boundary of this cosmic prison is known as the event horizon, and once an object crosses it, there's no return. There are three primary types of black holes: stellar black holes, which form from the collapse of massive stars; supermassive black holes, which reside at the centers of most galaxies, including our own; and intermediate black holes, which are thought to lie somewhere between the two. One of the most mind-boggling theories is that these supermassive black holes could be the engines powering the most powerful objects in the universe, quasars. What makes black holes so mysterious is that they challenge our understanding of the laws of physics. For years, scientists have been debating the information paradox, the idea that information that falls into a black hole is lost forever. This presents a fundamental problem because quantum theory suggests that information cannot be destroyed, yet black holes seem to do exactly that. Recent research into Hawking radiation and quantum mechanics could offer the key to unraveling these mysteries? Could black holes be the gateways to other dimensions or even other universes? What lies beyond their event horizons? Chapter 4. Neutron stars. Not all stars end in black holes. Some end their lives as neutron stars, incredibly dense remnants left behind after a star undergoes a supernova explosion. These stars are so dense that a single cubic centimeter of neutron star material weighs about 400 million tons. To put that in perspective, if you could somehow collect a teaspoon of neutron star matter, it would weigh as much as all the cars on Earth combined. What's even more fascinating is the speed at which some neutron stars rotate. The fastest known neutron star, known as a millisecond pulsar, spins at a mind-boggling 716 times per second. These objects also emit intense beams of radiation, allowing us to study their ultra-precise rotation and use them as cosmic clocks for measuring distances across the universe. Neutron stars are also known for their powerful magnetic fields. Some have magnetic fields that are over 1,000 times stronger than the most powerful magnets on Earth. These magnetic fields generate high-energy radiation that can sometimes be detected as gamma-ray bursts, one of the most violent phenomena in the universe. Could neutron stars be the secret to understanding the mysteries of gravity, time, and even life beyond Earth? Chapter 5. The Solar System. Our solar system, with the Sun at its heart, is home to planets, moons, asteroids, and countless other objects. The Sun, a G-type main-sequence star, is the primary source of light and energy that sustains life on Earth. But the planets that orbit the Sun are far more diverse than most people realize. There are the rocky planets near the Sun, Mercury, Venus, Earth, and Mars, and the gas giants further out, Jupiter and Saturn. Beyond these, we find the icy worlds of Uranus and Neptune, which are composed mostly of hydrogen, helium, and ices like water, ammonia, and methane. And far beyond Neptune lies the Kuiper Belt, home to dwarf planets like Pluto and countless other icy objects. But even farther still is the mysterious Oort cloud, a vast spherical shell of icy bodies that marks the outermost boundary of our solar system. The Oort cloud extends as far as 100,000 astronomical units from the Sun, and it is thought to be the origin of long-period comets that occasionally visit the inner solar system. Could the Oort cloud hold more than just comets? Could it harbor hidden planets or even rogue stars? Chapter 6. The Kuiper Belt and the Oort cloud. Beyond the familiar planets lies the Kuiper Belt, a region of space filled with icy bodies and dwarf planets, including Pluto, Haumea, and Eris. These objects are relics from the early days of the solar system, formed from the same material that eventually coalesced into the planets. They remain frozen in time, holding valuable clues about the solar system's formation. But the real mystery lies in the Oort cloud, a far more distant and enigmatic region. The Oort cloud is thought to be the source of long-period comets, which take thousands, even millions of years to orbit the Sun. While the Oort cloud has never been directly observed, its existence is inferred from the paths of these comets. Some scientists speculate that this region could also be home to rogue planets, planets ejected from their original star systems, free-floating in the darkness of space. The Oort cloud is thought to be located between 2,000 and 100,000 astronomical units from the Sun, well beyond the orbit of Neptune. It's so far out that we've yet to directly observe any objects within it, and it represents the unexplored frontier of our solar system. Could it hold the key to discovering new types of celestial bodies, or even alien life? What if the Oort cloud holds the key to understanding the formation of the solar system? Could it contain hidden massive objects yet to be discovered? Chapter 7. Quasars. Quasars are among the most powerful and luminous objects in the universe. These mysterious sources of energy are believed to be the active cause of supermassive black holes at the centers of galaxies. As matter falls into these black holes, it heats up and emits immense amounts of radiation, creating a quasar, an object so bright it can outshine its entire galaxy. The closest quasar to Earth is 3C273, which is still 2.4 billion light-years away. Quasars were first discovered in the 1960s, but we are still unraveling their secrets. They can emit more energy than 100 billion stars combined. A single quasar can emit as much energy as an entire galaxy, despite the fact that its visible size is often no larger than a typical solar system. Quasars are used by astronomers to study the distant universe, as their powerful light can be seen from billions of light-years away, allowing us to look back in time to the early stages of the universe. Could quasars be the key to understanding the formation of black holes and galaxies? Or is there something even more extraordinary at their core? Chapter 8. The Dark Side of the Moon. While the moon is a familiar companion in our night sky, there's an entire side of it that remains hidden from us. The far side, often mistakenly called the dark side. Despite the name, this side is not always in darkness. It experiences day and night, just like the near side. What makes the far side so fascinating is its mystery. Scientists have only studied it up close since 1959, when the Soviet Union's Luna 3 spacecraft took the first photographs. But what's really intriguing is that this side of the moon contains vast, unexplored craters, including one, the South Pole Aitken Basin, which is believed to be one of the oldest and largest impact craters in the solar system. Exploring the far side of the moon could unlock secrets about the early solar system and the history of our cosmic neighborhood, making it a key destination for future space missions. The far side of the moon holds a wealth of untapped knowledge. What might we discover when we finally unveil its secrets? Chapter 9. Rogue Planets. Imagine a planet not bound to any star, drifting aimlessly through space, untethered and lost. These rogue planets don't follow the predictable paths we associate with planets that orbit stars. Instead, they travel freely through the cosmos, some potentially ejected from their original solar systems, others formed in isolation in the dark reaches of interstellar space. While we used to think rogue planets were extremely rare, recent discoveries have shown that they might be more common than we imagined, possibly outnumbering stars in the Milky Way. Their conditions are harsh. Without a nearby sun, these planets are frozen and devoid of life as we know it. But could they still harbor the potential for life deep underground, where heat from the planet's core might provide the necessary conditions for microbial life to survive? Rogue planets are the lost wanderers of the galaxy. But could they still be hiding secrets that challenge our understanding of life in the universe? Chapter 10. Gravastars. As we explore the extremes of the universe, we encounter a fascinating concept that could challenge everything we thought we knew about the end of stars. Gravastars. These mysterious objects are theorized to be an alternative to black holes, offering a new perspective on what happens when a star collapses under its own gravity. Unlike black holes, which have an event horizon, the point beyond which nothing can escape, a gravastar would have no singularity at its center. Instead, it's theorized that as a massive star collapses, its core would transform into a state of exotic matter and energy, forming a stable shell of intense gravitational pressure around it. This would allow the object to maintain its structure without collapsing into the infinitely dense point we associate with a black hole. Gravastars challenge our traditional views on the fate of dying stars, suggesting that even in the most extreme conditions, there might be more to the story than we think. They could hold clues to the nature of gravity, space-time, and the limits of what we understand about the universe. Could gravastars be the missing link in our understanding of the universe's most extreme phenomena? And if they exist, what secrets could they hold about the nature of space-time itself? Chapter 11. The Multiverse. Theory: could there be more than one universe? The multiverse theory suggests that what we call the universe might just be one of many, each with its own set of physical laws, constants, and dimensions. Some versions of the multiverse theory propose that there are an infinite number of parallel universes, each slightly different from our own. Some might have different laws of physics, while others could have completely different outcomes from events that shaped our universe. The idea of the multiverse remains highly speculative, and there's currently no concrete evidence to support or disprove it. But it remains an exciting possibility, one that could explain some of the most puzzling questions in cosmology. If there are indeed other universes, they might be beyond the reach of our instruments and could never be observed, existing in realms we can't even imagine. What if the universe we know is just one of many? Could the secrets to our existence lie in these parallel realms? Chapter 12. The Future of the Universe. What will become of the universe in the far future? The fate of the cosmos is uncertain, and astronomers have proposed several possible endings. One scenario is the Big Freeze, where the universe continues to expand forever, cooling as stars burn out, leaving a cold and dark universe. Another possibility is the Big Crunch, where gravity might eventually reverse the expansion, causing everything to collapse back into a singularity. Or perhaps a Big Rip, where dark energy tears apart galaxies, stars, and even atoms. As we venture into the future, one thing is certain: the universe is far from static. Its mysteries will continue to unfold, with humanity possibly playing a role in unlocking its deepest secrets. Could we, in the distant future, have the technology to reshape the fate of the universe? Or will we be mere observers of its grand design? Chapter 13. The Final Question. As we gaze into the vastness of the cosmos, we are reminded of our own fragility and the sheer scale of existence. We are but a tiny speck in an ever-expanding universe. Yet this knowledge brings us closer to understanding our place in it. The pursuit of knowledge has led to the most remarkable discoveries about the universe, from the birth of stars to the potential of other worlds beyond Earth. But the most profound question remains: what is our purpose in this cosmic journey? Are we the only conscious beings in the universe? Or are there others like us, pondering the same mysteries in distant corners of space? The universe is a never-ending journey of discovery, full of questions, challenges, and untold mysteries. As we continue to explore the stars and the depths of space, one truth remains clear: the more we learn, the more we realize how little we know. The universe in all its complexity will continue to surprise and astound us. And who knows what secrets lie just beyond our reach? The universe is vast, infinite, and full of possibilities. What will we discover next? Stay curious, because the adventure is far from over.